Hi, Kristen. Yeah, I can understand your confusion. The mark scheme is a bit weird for this one. But essentially, whenever you get these questions to sum things up and it asks you to use partial fractions, we're going to use the method of differencing that we did in year 12. So I'm very quickly going to check what the partial fractions are. So set it up. And then if we times through by the denominator, we'll get this. And then we can choose R to be 1. And that means that B is equal to 1. Because we get 3 in that bracket. And it cancels with that. And then if we do R to be negative 2, that means A is going to be negative 1. So that's the start bit. I'm sure you did that. So we've got that algebraic fraction. It's probably easier if I write this second because it's subtracted. So I'll have 1 over R minus 1 minus 1 over R plus 2. Okay, because these are subtracted and sigma is summing things up, we can write those separately. So if I had the sum from the fifth term of this all the way up to n, that would be the same as adding up. Oh, whoa, what was that? That'd be the same as adding up all of these partial fractions and then taking off all of these. Okay. Now they've actually made it so that you have to do it this way, because if you found all the values from r equals 1 up to n and then took away the first 4 terms, it won't work. Because when you substitute in 1 into there, you get 0. So they've actually engineered it so you have to do it this way. So now let's refocus. We're going to set up like our little grid and see what will cancel out. So the first term that I'm just going to copy this. The first term that I'm going to substitute into this is going to be r equals 5. And then I'm going to build up and see if I can spot a pattern as to what's going to cancel out. So I'm probably going to need a few more rows. So when r equals 5, I get a quarter, a fifth, and on the other side, I'm taking away a seventh, an eighth. So I haven't got anything that cancels yet, but it looks like fairly quickly we're going to get some cancelling, which is good. So I get a sixth, a seventh, there you go, that's going to cancel with that seventh at the very top of the second column. Let's just do a couple more. R equals 9 will give me 8, and then they're basically just going up in ones. So if we analyse what would happen if we just keep going, that term, and that term will not cancel with anything because the denominator is getting bigger. But that will cancel with that term. So the first one will cancel with the fourth there. And that pattern will stay the same all the way down. So if I, say, added another row, say my n was up to 10, that 9th now cancels, but I get this extra 12th that hasn't cancelled when I've got up to that point. So what that means is however far I go down this list, the ones that won't cancel out are these 3 and the final 3 from that row. From that column. So that means if I go down to n, I'll get n plus 2. That was right, wasn't it? Yeah. And then, but I've got to go up 2 more positions. So n plus 1 and then n. And all of those are negative. So now we're going to summarise it. That's enough working. We can say that when we do the sum from 5 to n of r plus 1 minus the sum from 5 to n of r minus 2, plus 2, apologies. I think it's plus, oh, I got the minus, duh. That is equal to, zoom out, a quarter plus a fifth plus a sixth minus 1 over n minus 1 over n plus 1 minus 1 over n plus 2. Lowest common multiple, so we would have 20, and then so 60 is going to be our lowest common multiple there. And I'm just going to add it on the calculator, Kristen. I'm sorry. I know I should be able to do it, but I'm not going to. Ah, good. I think that's the right answer. 37. To get a little bit nervous there for a minute, because 37 being prime was a. But I think that's right. Let me just double check the question that you sent me. Where are we? So, yay, we did it. Okay, so we managed to get that. In your message, say like re-index it. That is not. I don't know why the mark scheme would do it that way. It is genuinely not the easiest way to do it. And there won't be a time where you can't do this method of differencing. That's why we spent quite a lot of time doing it last year. It's the easiest way, like spotting that pattern. Okay. Yeah, so I hope that helps. The last bit is to say what happens when it tends to infinity. So we can basically just analyse that these would tend to 0 and this would be the solution. Okay. Yeah, hope that helps. Keep up the hard work and let me know if there's anything else.